Hey everybody, this is a practice problem on work and kinetic energy, work and energy. This is a problem in which we find the net work done by a net force, in which there are a lot of different forces acting. So let's get right to it. A 65.0 kilogram cadaver is pulled along a rough surface, mu d equals 0.220, with a force of 520 newtons at an angle of 40.0 degrees above the horizontal. It is pulled for 4.50 meters. Find the work done by the net force, which is also just the net work. So there are two ways we could do this, but either way we're going to need to start with the free body diagram, so let's do that. The forces acting on our cadaver are going to be, we have a downward force of gravity, mg. We have an upward normal force. I'm going to write it as r. We have a pulling force at an angle of about 40 degrees. I'm going to label it Fa. And let's see, what else do we have? Well, we have friction. Friction. I drew Fa in blue because I know that we're going to have to break it into its components. So I'm just going to do that right now. We're going to have Fax and Fay, and we know this angle is 40 degrees. So let's just, well, if we're going to find the work done by the net force, we need to find the net force, or we need to find the work done by each force and then add up the works. So I'm going to find the net force, so I'm just going to start filling in what we know. Because m is 65 kilograms, mg is equal to 65 kilograms times 9.81 meters per second squared, which is 65 times 9.81, 638 newtons. Fill that into my diagram, 638 newtons. My applied force is 520 newtons. So I can find the components of that applied force. The x component is just going to be, since it's the adjacent leg, it's going to be cosine, so 520 newtons times cos of 40 degrees. Which is 398 newtons. And the y component is going to be, well, it's sine because it's the opposite leg, 520 newtons sine of 40 degrees is equal to 334 newtons. So let's fill those in on my diagram as well. The x component is 398 newtons, 334 newtons. So now I can find the normal force. The normal force is not equal to mg. They do not cancel because there's another force acting. If there were not this y component of the applied force, then the normal force would equal mg. However, because we're partially pulling up on the object, the normal force does not have to be as strong. However, we do know there is no up-down motion, so gravity doesn't cancel with the normal force, it cancels with the combination of the normal force and the y component of our applied force. So we can solve for r. We get r equals mg minus our y component of that force, which is just going to be 638 newtons minus 334 newtons. So our normal force is then equal to 638 minus 334, 304 newtons. And I'm going to fill that in on my diagram too, 304 newtons. Once we have our normal force, we can get the frictional force, because we know friction, kinetic friction at least, or dynamic friction, is mu dynamic times our normal force. We know mu d is 0.220. My normal force is 304 newtons. So our force of friction is then equal to 66.9 newtons. Okay, so that's all of the forces. Now we need to actually find the work done by the net force, so we need to get the net force. Well, we know our net force is in the x direction, so let's look at the net force in the x direction. The only forward force is Fax, the only backward force is friction. So our net force is just going to be 398 newtons minus 66.9 newtons, which gives us a net force of 331 newtons. And if we want to find the work done by that force, work is equal to force times displacement times cos of the angle between those two. Well, we know the force, the net force is 331 newtons. We know the displacement is 4.50 meters. And since it's being pulled to the right, and the net force is also to the right, so our angle is zero, so it's cos of 0 degrees, which means that just goes to 1, and we get 331 times 4.50, which means we have 1,490 joules of work done, or 1.49 kilojoules. That's that. If you want to find the net force, the net work when there are multiple forces acting, you just find the net force and then use the work formula. An alternate method would be to find the work done by each force. There's actually only work done by Fax and force of friction, and add them up. You should get the same answer, because your work done by this Fax will be positive, your work done by Ff will be negative, and they'll end up giving you 1.49 kilojoules of work. Hope that was helpful. Bye.